GEOSA is a small, privately owned, Arreston-based company specializing in a variety of aspects of underwater research and development. Since 1992, we have been an incubator for innovative ideas, tailoring these to a broad spectrum of underwater applications, from small-scale pilot research projects to large-scale, fully operational, MOD-funded projects. Our primary research vessel is the Terschelling, a 40-meter-long converted Dutch naval vessel. She is multifunctional and a versatile platform which can be configured to be anything from a 19th century steamship, as used whilst filming Daphne du Maurier's Rebecca, to a deep-sea exploration platform or a refined research vessel. Equipped with a 4-point mooring system, Terschelling has the flexibility to move anywhere within the work area, and once there, to maintain position. A major element of our work is the design and construction of highly specialized underwater vehicles, such as this crawling excavator, supporting tools especially designed and made in-house for excavation and recovery, and used on the historic wreck of the Mary Rose. The hub is the control room. The vehicle operator can watch what is happening in several dimensions. Direct video from cameras mounted on the vehicle, together with sector scanning sonar and acoustic positioning, provides real-time, real-world visuals and coordinates. The vehicle is capable of many different applications, such as the excavation of this 18th century shipwreck using a combination of air jetting and air lifting to remove sediments to reveal objects and timbers. Shown here, the excavation trench is being separately lit by a secondary, free-swimming highball ROV, providing overall views of the excavation areas. Images from all cameras are instantly backed up on video or DVD. Divers can work alongside these machines to delicately expose and record artifacts. It is equipped with a wet bell, enabling 2 diver operations using mixed gas or air. The entire diving and handling system was devised and built on site in Arreston. The wet bell offers safe and easy access directly to the workplace. It is rigged with lights, cameras, microphone and a separate air supply, making for a safe refuge and comfortable decompression stops. Recent work on the site of Henry VIII's Mary Rose between 2003 and 2005 included the finding, recording and lifting of this 5-ton wrought iron bow anchor, together with a 10-meter-long composite timber which originally formed the stem of the ship. These can now be reunited with the major section of the hull lifted in 1982 and displayed within Portsmouth Historic Dockyard. The lifting capabilities, combined with adequate deck and indoor dry space, means that the reception, registration and holding of objects and timbers can take place. Terschelling was a support vessel for the Time team when they made their first underwater documentary and for a children's TV program on the corrosion of metals using the historic wreck Resurgam, a submarine boat which sank off North Wales in 1859. This became one of the largest amateur diving projects undertaken in the UK, using the government's Marine Archaeology Unit together with amateur archaeologists from the Nautical Archaeology Society, and combining the multidisciplinary skills of marine biologists, archaeologists and oceanographers. The Marine Investigation Unit of the MOD used Tershelling to undertake a detailed survey of the naval submarine M1 to ascertain the reason for the sinking. Found in 90 meters of water south of Plymouth, a video survey of the hull reveals the impact hole causing a breach in the ballast tank, resulting in instability. The same contact ripped the gun off its mounting, leaving a 6-inch hole, flooding the submarine. The slip ring of the gun mounting is still visible. This 18th century schooner was found by the crawling Sea Cat whilst undertaking corridor searches of the ocean floor for the MOD. Locating objects using sonar, Sea Cat moves up on them and deploys a highball ROV from a dedicated garage on the back of the vehicle. Adapted to carry a number of experimental sensors, this 7-function manipulator, also built at Arreston, can recover delicate objects encountered during forensic operations. Tershelling is capable of deploying a number of vehicles simultaneously. One of these is Sea-Sub-2, also designed and built in the GEOSA workshops. Designed primarily for excavation and burial, Sea-Sub weighs 5 tons and can operate in depths of up to 1,500 meters, either manned or unmanned. Sea-Sub is fitted with scanning sonar, an acoustic position system, and video cameras to enable the recording of all work undertaken. Sea-Sub is shown here functioning as an underwater JCB. She is filling a skip with unwanted spoil at a depth of 170 meters on the sea floor in the Bay of Biscay, then carefully removing debris prior to commencing of trenching operations. Positioning is achieved using acoustics, and Tershelling has been used as a base for trials with the local Turnchapel company Sonardyne International, world leaders within the field of underwater position fixing systems. GEOSA is also at the forefront of the development of seabed survey, utilizing multi-beam to produce 3D images which can then be inverted and rotated to produce a topographic map of the seabed, showing detailed landscapes from which accurate measurements can be taken. One long-standing research partner is the National Oceanographic Centre at Southampton and their AutoSub program. AutoSub, shown here in Norway, is a non-tethered, unmanned submarine. Tershelling was the base and laboratory for the first ever AutoSub mission and continues to be used for this pioneering work, often in conjunction with other partners, such as Plymouth Marine Laboratory. AutoSub can be configured with different scientific instruments within the specially designed gantry and shelter on the back deck of the Tershelling. AutoSub has now completed 360 missions over the last 6 years of this partnership, with a maximum endurance of 4 days and 2,000 meters under the ice. GEOSA designed and built this proxy iceberg, hanging beneath these buoys in Plymouth Sound, to test how the AutoSub would respond to underwater obstructions. Field trials in the fjords of Norway, also using Tershelling, prepare AutoSub for her ultimate mission under the Antarctic ice to provide data on the melting ice caps to provide valuable information on the speed and extent of global warming. Tershelling provides an unparalleled base of operations and GEOSA the skills and creative design that make this possible. The shore facility is also used as a base and workshop for visiting scientists and engineers, as well as for specific courses, such as this course in the recording and conservation of artifacts from shipwrecks undertaken for the Nautical Archaeology Society. To ensure that the pioneering work of this unique local enterprise continues to flourish, we need to expand the Arreston facility to provide accommodation, a secure compound, and dedicated laboratory and workshop spaces for visiting scientists, engineers, and partners.